What we're going to take a look at today is something called slope. This is a way of describing a linear function or a linear relationship. And there are a number of ways that we're going to do it, but today's lesson, and the one that we're going to look at specifically today, is slope. So a linear function can be described in several ways. One of them is called the rate of change, also known as the slope of a line. Okay, so we're looking at the rate of change. It's also called the slope of a line, and we're going to specifically look at the term slope in this case here. The rate of change is a way of describing how the y value is changing each time the x value goes up by 1. Okay, so if we take a look at like patterns that we've looked at in the past, or stuff that we've looked at that is going up in a linear fashion, like this one here, 1, 3, 5, 7, we can think of this as a little table of values where x and y are first, second, third, fourth terms. First term is 1, second term is 3, then 5, then 7. X is going up by 1, right? Each term is going up by 1, and the y value, or the pattern that we're seeing, is going up by 3. Okay, or sorry, going up by 2s. Okay, so the y value is going up by 2s every time that the x value goes up by 1. This is a way of describing the pattern. For the previous example that we did there, the x value is always going up by 1. So the rate of change can be determined by the difference of the y's. Okay, so the difference of the y's represents how it is changing because x is going up by 1. That's not necessarily always the case because we don't necessarily always have a nice chart where the x is going up by 1. Sometimes the x is going up by something different and the y is also going up by something different. So if the x value is going up by something other than 1, the rate of change, or what we call the slope, and we're going to use the letter m, okay, so I'm going to use the letter m to represent slope, can be found by using any 2 points and the following formula. Okay. Our formula that we're going to use in this case here is that m is equal to the change in y divided by the change in x. And we're going to get to some more specific formulas as well, or specific ways of describing the formula, but for right now that's the way that we're going to represent it. It's the change in the y divided by the change in the x. In this case here, the y's are always going up by 2, the x are always going up by 1, so the slope would be 2 divided by 1. Okay, so that's just the difference. 2 divided by 1 being 2, it's going up by 2's. That's our slope that we see. The slope of a line represents the way that the line, so this is when we're getting into linear equations, the line is angled, okay, in respect to the horizontal. Remember that horizontal is flat, okay? It's flat, that's the horizontal. So in respect to the horizontal is going to be the line. So a slope of a horizontal line would have a slope of 0, and then as we start tilting it, it's going to have more of a positive, bigger number, bigger number, bigger number, and then when we get to a vertical line, then it's actually undefined, and then we're going to get negatives on the way down back to a horizontal. Okay, but we'll talk a little more about that as we get going. It can also be thought of as the steepness of the line, okay? And the slope represents the rate of change of a line in relation to the horizontal. Okay, so that's how we're going to represent, or that's what slope represents, and how we're going to deal with our slope. So let's take a look at some examples of a roof line. Now a roof line, you've probably seen them around, whether it's a house or a business or something along those lines, and they may have a slanted roof, something like this here. We have 3 roofs, 1, 2, 3, and each one has a different steepness. You can probably assume of which one is the steepest one, middle one, and which one is the least steep, this one here. But we can also represent it with a number. So we're going to take a look at the slope of each of these roofs. And to do that, we're going to make a little bit of a triangle here, okay, which is going to go from the peak to the outside here. And it's going to be a little tough to see, or it is a little bit tough to see that. What we have is from this point here to this point here, we have a rise, 1, 2, 3, 4, 5, 6, 7. And we have like a vertical component, and we have a horizontal component. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Remember that our slope is the change in y over the change in x. The change in y is our vertical, so 7, over the change in x, which is our horizontal, which is 10. So our slope here is 7 over 10. Okay. And if we want to put that into a decimal form, that would be 0.7. We don't necessarily have to, but we can put that into decimal form as well. Let's take a look at this one. Let's do the same thing. Let's go from this point to this point here, and I'm just going to draw just above the line so we can actually see that. We have a horizontal piece, 1, 2, 3, 4, 5, 6, 7, 8, and a vertical piece, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so our slope here, again, is the change in y over the change in x, okay, which would give us a 5 over 4 simplified, or a 1.25 slope. You can see this one is a higher number than this one here. So this one is a steeper slope, which we kind of already knew, or we should have known based on what we can see. The last one, there's our vertical component. Here is our horizontal component. Again, going to be kind of tough to see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11. It is up 3. So our slope is 3 over 11. Which now we're going to try to do it nice and quickly here. This one I can't do in my head. 3 divided by 11 is 0.28, and that's rounded. It's 0.27 repeated. But we can see specifically this is a much lower slope than either of the other two, which kind of makes sense based on steepness. Okay, we can understand that with steepness. Now, the slope of the line can be found between any 2 points that are along a line. I decided to choose the top and the bottom, but if we had another nice point somewhere along the line, like here we could do this point and this point, it's 4 and 5, there we go, right there, okay, we would find the same slope. All sections of a line have the identical slope. Okay, so all sections of the line have the exact same slope, no difference there, and we can, remember it's equal to m, we can think of it as the rise of a line divided by the run. Rise divided by the run, and the run is going to be horizontal, and rise will be the vertical. Okay, so this is the vertical change over the horizontal change. Okay, vertical change over the horizontal change, which is another way that we can describe the slope. All right, let's take a look at the next page that we're going to go through here. All right, the slope of a line, okay, again, like I talked about, can be found using the rise and the run. Now we're going to move into a linear equation here when it's graphed out as a linear function. And again, this is always working from left to right. Okay, so it's always going to be working from left to right. Let's determine the slope of this line right here, and we're always going to do it, we're going to leave it as a fraction. We could do a decimal as well, but we put it as a fraction to make sure that it is in exact terms. Our slope is always going to equal the rise over the run. Okay, it's always going to be the rise over the run. And so in this case here, what we'll do is we'll draw it out. I'm going to draw out a triangle like this. So I got 1 point here, 1 point there. There's going to be the rise. Here's going to be the run. I'm going to draw it out as a triangle. If you have a graph, you can do that. This one's not labeled. We're going to assume it's going up by ones. If it's not going up by ones, it's a little different. But we have a rise 1, 2, 3, 4, 5, 6, 7. A run of 1, 2, 3, 4, 5, 6, 7, 8. And so our slope is 7 over 8. 7 over 8 is our slope. So that would represent how steep the line is. Now, we're not going to worry too much about angles at this point here, but the bigger the angle going up, okay, the bigger the number is going to be, and it's represented through our slope. Now, there are 4 different types of lines that can be drawn, okay? The first one is going to be what we've seen so far. It's going to be a line that looks something like this here that goes from low to high, okay? It goes from low to high. This is going to give us a positive slope, okay? It rises from left to right, like we're walking up a hill. So think we're going left to right, okay? It's the way we read books. It's the way we read all words. All words are lettered wise from left to right. We're going uphill, okay? We're going uphill, it rises. That's going to give us a positive slope, just like this one did. It's a positive slope. It's going up. We could also have a line that looks like this, okay? It's going in the opposite direction. This one drops from left to right, like we're walking down a hill, and will give us a negative slope, which we're going to take a look at in future examples, but we haven't seen one yet. So this will give us a negative slope. It means that it's going to be going downhill. Then we're going to have one that gives us a perfectly straight horizontal line, and I'm going to do my best to do a horizontal line. This is going to be a horizontal line, okay? This is like y equals 2, like a line like that. That's a horizontal line, okay? So again, horizontal line, it has 0 rise, but it has whatever run we want to give it. This one has a 0 slope. Okay, so m equals 0. 0 divided by anything is 0. So it's going to give us a 0 slope. And finally, we're going to draw a vertical line. And again, I'm going to try to draw it as vertical as possible in accordance with this graph. We have a vertical line. Let's say this is something like x equals 2. That would be a vertical line. This has 0 run. There's no run, but it has whatever rise we want to give it. That has a slope, or sorry, that has an undefined slope because we cannot divide by 0. Okay, we can't divide by 0. It is mathematically impossible to divide by 0. It's going to give us an error. So if you do any calculation on your calculator, 9 divided by 0 is going to give us a math error. So it gives us an undefined slope. It's a vertical wall, if you want to think of it that way. Okay, we can't walk up that. You got to climb it up if you really want to. Okay, let's take a look at using a formula to find slope. Okay, so this is on that next page. This is page 14 of the booklet if you're following along. If you're just going through it, sorry, I have some booklets that I go through in my class. Slope can be found using the graph, which we have done already, or using a formula. Okay, the ones that we've taken a look at so far are that slope is equal to rise over run, or the change in y over the change in x. So let's say that we're given 2 points. We're given that a line goes through the points 2, 4, and negative 1, 6. Now, what I'm going to do is I'm going to plot these ones really quickly here on a little graph. I'm not going to do it accurately, but I'm just going to kind of give us a little bit of a look as to what this line would look like. So let's say that we have the point negative 1, 6, which would be somewhere around here. Okay, this is negative 1, 6. And we have the point 2, 4, which would be somewhere about there. Okay, and then we're going to have a line going through. And this is a really rough sketch. Okay, there's nothing exact about it. It's a really rough sketch, but there's what our line would look like. Okay, going through those 2 points. Now, I don't have graph paper to go through it. So in other words, what we're going to do is we're actually going to come up with an equation that lets us figure out what our slope is. So the first thing we're going to do is that the change is found by subtracting one value from another. So to find the rise, we're going to subtract the 2 y values. And what we're going to do is we're going to label this as x1, y1, and x2, y2. So this is point 1, point 2. Order does not matter. You can do either order, but that is kind of the way that we can do it. So we're going to find the rise, we're going to take the second one, we're going to subtract the first one. And so this gives us the second one. So 6 minus 4 is equal to 2. Okay, so that one is 2. So y2 minus y1 gives us 2. There's our change in y. Now to find the run, we subtract the two x values. Okay, and when we subtract it, be sure that you subtracted the two values in the same direction or same order as you did the y value. So we did y2 and y1, so we're going to do x2 minus x1. Now x2 is over here, -1 minus 2 gives us -3. Okay, so we've done that, and now we need to create a fraction with the rise and the run to find the slope, and a positive slope represents going up, and a negative slope represents going down. So our slope in this case here, let's keep using the same color, m is equal to the rise of 2, the run of -3. So this would give us a -2/3 slope. It means we're going down, which we can see. This is going down. Now, what does this do here? Well, it gives us a really nice equation that we can use. Okay, a really nice generic equation, 0.1, 0.2, x1, y1, x2, y2, and we can put them into our slope formula. Y2 minus y1, there's our rise, over x2 minus x1, which is our run. Okay, so remember, this is the change in y, right? So we're just going to go through the last 3 examples. I have them written down already, so I'm just going to go over what they look like. But to find the slope of each line, we have to do the rise over run. So we have this line here, line A. Okay, line A. I've given you 2 points. This is -5, 1 and 3, 3. If we put a triangle through them here, this is going to give us a run of 8 and a rise of 2. Now working left to right, that's positive, so it's going up 2 from there. So that's going to have a slope of 2/8, which is equal to 1/4. This next line here, we're going, so for B, we're going down. Okay, so from here to here, it's going down 2, so I give it a -2, +5. The run is always positive, so go -2/5. So we have a slope of -2/5. Leave it just like that. It's already simplified. And the final one here, C, we have this triangle right here. It's going down 7/2, so it's a -7/2. We'll leave it exactly like that. You could technically put it into a mixed number if you really wanted to, but I would recommend just leaving it as an improper fraction. It just goes a little bit, it's a little bit easier to see a little later on when we start using them. Now, if you're working through my class, we're going to work on assignment Li.03, numbers 1 to 5. That is the first section we're going to go through, and then you can watch the next video, and that will give us the remaining remaining part of the assignment as well.